Hello and welcome back to another Orange Coast College mathematics video. In this video, we are going to continue our discussion of graphing trigonometric functions. We have to talk about the last two, secant and cosecant. And our process is going to be very similar to the last couple of videos when we graph the other trig functions, which is to find a period, to find how much it's stretching or compressing vertically, are there any shifts, etc. In this video, you'll notice that because cosecant and secant are the reciprocals of sine and cosine, we end up with this sort of flipped idea. In these red dotted lines, you're going to see that we have the graph for cosine and the graph for sine. And in green, we have the actual graphs for cosecant of x. When sine is 1, cosecant is 1 because it's just the flip of it. But for these smaller sine values, we're getting larger values of cosecant. And at pi, for example, when the sine is 0, the reciprocal of 0 is undefined because we would be dividing by 0. And that's why we're getting a vertical asymptote and this graph shooting off to infinity. So graphing this is going to be pretty similar. In fact, what we're going to do is we're going to graph these as if they were sine or cosine, and then use that to graph the appropriate cosecant or secant function. So let's go ahead and just jump in with an example to see how this works. In this problem, we have y equals 2/3 cosecant, but I'm going to, for right now, focus on sine, which is the reciprocal of cosecant. Sine of x plus pi over 4. So I'm going to do everything for sine, but I'm going to graph it as kind of a dotted line so that we can then graph the actual cosecant graph afterwards. So for sine, it looks like that we've got a period of just 2 pi, because b is just 1 in this problem. We've got an amplitude of 2/3. All of this stuff applies to the sine graph, right? We're graphing sine right now. We've got a shift of pi over 4 to the left. And so because our period is 2 pi, we're going to be counting by 2 pi divided by 4, which is pi over 2. So when I sketch this picture, what do I have? I've got a negative pi over 4, and then I have to add by pi over 2. So that's going to be positive pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So that takes care of my period and my shift. My amplitude is going to be 2/3. So I guess I will graph this with, it doesn't matter too much. I guess I could put 1 and -1 here, which means this would be where my 2/3 is, right? This right here is where the 2/3 is going to be. And now what? For graphing sine, I'm going to do what? Sine starts at 0, so I've got 0, then up at the amplitude, then down at 0, then down at negative the amplitude, and then back to 0. I'm going to go ahead and sketch this, though, using a dotted line because the sine graph is not actually my answer. It is just a tool to help me graph the cosecant function. So now that I have sine graphed, I can introduce my asymptotes. I'm going to get asymptotes everywhere that sine is 0 because its reciprocal will be undefined. So that's going to be here, and here, and here. And then so my actual final answer is going to be the little U shapes. They're not actually parabolas. I know they kind of look like it, but they're not. They're asymptotic. And that will be my graph for this cosine function. Okay, let's go ahead and try another one. This one with 3 plus the secant of 2x. So I'm going to start by recognizing again that I'm going to graph this really as the cosine of 2x, 3 plus the cosine of 2x, and then graph secant in the end. Well, the period here is going to be 2 pi. If I cut that 2 pi into 4 pieces, I end up with pi over 4 is what I'm going to be counting by. My amplitude, again, for this cosine graph is 1, hasn't changed. And I do have one shift. I'm going to go up by 3. All right, so how does that shake out here? Well, no horizontal shifts. So because this is going to be cosine, we'll start with a period to the right. And then I'm going to have to count by pi over 4. So 1, 2, 3, 4, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and pi. Then because we're doing cosine here, so that takes care of the period, but I am shifting up by 3. So because of that shift, I actually might instead want to move this axis down a little bit because of that vertical shift, just to give me a little bit more space to work with. And so because of that vertical shift of 3, I've got my sort of equilibrium point at 1, 2, 3. This is going to be sort of that equilibrium point where my graph is going to start and stop. So for cosine, I'm starting at 0 at plus 1. Then I am going to equilibrium, then I'm going to go down, then back to equilibrium, and then back to 1. And so using my dotted line for the cosine, I get a wave that looks kind of like this. And then we proceed to sketch our asymptotes where we see, we proceed to sketch our asymptotes where we see cosine reach this equilibrium here and here. So here I'm going to get my little like U shape. Over here I've got half of a U shape, and here I've got half of a U shape. Now remember, just like all of the other trig functions, this goes on forever. This is one period, but it's not like that actually stops here. So if you wanted to continue the pattern and recognize that it's going to look like this and look like this to finish it off, you certainly could. That's a little bit more than a period now, but maybe it gives a better picture of what's going on in this problem. All right, let's try one more. In this problem, we're going to graph cosecant. So again, I'm going to start by graphing this in as if it were -2 sine of pi over 2x. And then we'll deal with making sure we actually graph the cosecant at the very end. Well, in this problem, we've got a period of 2 pi divided by that pi over 2, which is the same thing as 2 pi times 2 over pi, which is 4. Cutting 4 into 4 pieces makes it counting by 1. That's pretty nice to work with. My amplitude is going to be 2. Again, that's the amplitude of the sine graph. Cosecant is not a wave, so it itself does not have an amplitude, but we're graphing sine right now. And there's no shifts. So, but we do have this negative we're going to make sure we need to contend with. So let's go ahead and set up my axis. We're here. No vertical shifts, so we can probably just draw this right down the middle. I've got an amplitude of 2, so we'll go up 1, up 2, down -1, down -2. And we've got we're counting by ones, 1, 2, 3, and 4. So sine would normally start at 0, which it's still going to in this problem. We're going to start at 0. But now normally sine would go up, but because of the negative, I'm going to get, at 1, I'm going to get -2, then back to 0, up to 2, back to 0 because of that negative. And so my sine graph, if I draw it with a dotted line, is going to look something like this and finishing off like this. And so we get our vertical asymptotes everywhere that this is at equilibrium, because that's what's going to make this undefined and go off to infinity. And then for the final answer, we just fill in our little U shapes. And so this blue graph, again, is actually the graph of cosecant. All the other dotted things you see here are just to help us graph that. But the blue is actually the graph of one period of cosecant. All right, that will conclude this video. If you're ready, you may move on to the next one.